Hello friends, I am your chemistry faculty from QLS Academy. Today we are going to learn about arrangement of electrons and how their arrangement affects the properties of the atom. Hope you will enjoy today's class. So now let's get started with our today's lesson. In previous class, I said that chemical properties of elements are influenced by the number of electrons. Actually, it is the arrangement of electrons which decides the chemical nature of an element. In 1912, Bohr and Bury suggested the distribution of electrons into different shells of an atom. They postulated that electrons revolve around the nucleus in their assigned shells. Bohr named those shells as K, L, M, N and so on. And each shell has a fixed energy. These shells are also denoted as small n, which is 1, 2, 3, 4 and so on. These shells are also called as orbits. The arrangement of electrons in these shells is known as electronic configuration. Friends, you know that किसी भी काम को करने के लिए कुछ rules and regulations होते हैं. Similarly, there are also some rules and regulations to write electronic configuration. Now, we are going to study the rules which should be followed to write the electronic configuration of any element. First rule, the maximum number of electrons that can be accommodated in any energy level of the atom is given by the formula 2n square. Here, n is the number of that energy level. Remember, हमने कहा था n is equals to 1, 2, 3, 4 and so on. According to Bohr's atomic model, the first energy level means shell 1 or shell K can accommodate only 2 electrons. Here, n is equals to 1, so by putting the value of n in the formula 2n square, you can easily determine the number of electrons in a particular shell. Similarly, we can determine the number of electrons in other shells. The maximum number of electrons which can be accommodated in shell 2 or shell L is 8. For shell 3 and 4 or shell M and N, maximum number of electrons that can be accommodated are respectively 18 and 32. The second rule, the electrons in an atom do not occupy any shell until and unless all the inner shells are completely filled. जब तक कि अंदर के शेल्स जिनकी एनर्जी लेवल कम है वो जब तक फिल नहीं हो जाएंगे तब तक अबव हायर एनर्जी लेवल के शेल्स भी फिल नहीं हो सकते. Hence, filling of electrons in atom follows a stepwise approach. पहले लोअर एनर्जी वाले शेल्स में इलेक्ट्रॉन फिल होंगे, देन हायर एनर्जी लेवल में. The third rule, the maximum number of electrons that can be filled in a valence shell is 8. Even it has a capacity to accommodate more than 8. हमने अभी अभी देखा कि शेल M and N में 18 and 32 electrons accommodate कर सकते हैं, but in actual they cannot hold more than 18 electrons in a single shell. हमने अभी अभी देखा कि शेल M and N में 18 and 32 electrons accommodate कर सकते हैं, but in actual they cannot hold more than 8 electrons in a single shell. After a detailed study, scientists like Louis de Broglie, Schrödinger, Sommerfeld and others proved that shells or energy levels have sub-shells within them. अब तक हम सिर्फ shells की बात कर रहे थे, but now shells have shells in them. Shells के अंदर और भी shells होते हैं. We call them as subshells or orbitals. Electrons are distributed in these subshells. The various orbitals are s, p, d and f. Every subshell can accommodate a fixed number of electrons. Like s subshell can accommodate a maximum of 2 electrons. A p subshell can hold a maximum of 6 electrons. D subshell can hold a maximum of 10 electrons, while f subshell can hold a maximum of 14 electrons. Now let's see an example to understand electronic configuration better. Let's see the arrangement of electrons inside sodium atom. Sodium has atomic number 11 and mass number 23. Atomic number and mass number के बारे में हम already last class में पढ़ चुके हैं. Atomic number is the total number of protons present in the nucleus of an atom. You might remember that in an atom the number of protons is equal to the number of electrons. So, when we say that element Y has atomic number P, this means the atoms of Y contain P number of electrons. Here, we can now clearly state that sodium contains 11 electrons revolving around its nucleus. So, Keeping in mind all the rules to write electronic configuration, the electronic configuration of sodium will be shell K or shell 1 will have 2 electrons, shell L or shell 2 will have 8 electrons, while shell M or shell 3 will have only 1 electrons. Therefore, electronic configuration of sodium atom is 281. Now, come back to the chemical properties of an element. The arrangement of electrons decide the chemical nature of an element. How? The electronic configuration of an atom decides its valency, which is the far most important feature of any atom. Valency of an atom dictates all of its chemical as well as physical properties. The electrons present in the outermost shell of an atom are called valence electrons. They decide the valency of the atom. Means ये decide करते हैं कि एक atom और कितने atom के साथ combine हो सकता है to form a simple molecule or a complex compound. Outermost shell में sodium के पास सिर्फ एक ही electron है. Hence, the number of valence electrons present in sodium is 1. Sodium के पास सिर्फ एक ही valence electron है. Now, the chemical properties of an atom are dependent on these valence electrons because they are the ones which participate in all the chemical reactions. Elements having valence electrons 1, 2 or 3 are called metals. जिन elements के outermost shell में 1, 2 या 3 electrons present होते हैं, they are considered as metals. But there is only one exception to that, hydrogen. Hydrogen has one valence electron, but it is not considered as a metal. These elements lose electrons easily and form a positively charged ion called cation. Last lessons में हमने देखा था कि atom में equal quantity में positive and negative charges present रहता है. And that's why an atom is always neutral in charge. But when the quantity of any one of the charged species is disturbed, the neutrality is lost. Loss of proton is rare, but the loss and gain of electrons is very easy and is the basis of all chemical reactions. जब किसी atom से electron lose हो जाता है, it gets a positive charge. While when an atom gains some extra electrons, it gets negatively charged. Metals have the ability to lose electrons, so they are often converted into cations. For example, sodium, it loses an electrons and becomes sodium positive cation. Now, the elements having 4, 5, 6 or 7 valence electrons are considered as non-metals. They tend to gain electrons and turns into negatively charged ion, anion. For example, chlorine. Chlorine has atomic number of 17 with electronic configuration 287. Chlorine mostly gains an electrons and becomes chloride ion. Atoms containing less than 4 electrons in its outermost shell have valency equal to the number of electrons present in the valence shell. For example, sodium has 1 electron in its outermost shell, so the valency of sodium is 1. Calcium has 2 electrons in its outermost shell, so its valency is 2. Aluminium has 3 electrons in its outermost shell, so the valency of aluminium is 3. When the outer shell has more than 4 electrons, valency becomes 8 minus the number of electrons in the outer shell. For example, oxygen has 6 electrons in its outermost shell, so the valency of oxygen is 2. 8 minus 6. Elements with same number of valence electrons will have similar chemical properties, whereas the elements with different valence electrons will have completely different chemical properties. An element with 8 electrons in the outermost shell is said to possess an octet. जिन elements के outermost shell में पूरे complete 8 electrons होते हैं, they are said to possess octet configuration. Elements with the octet configuration are considered as stable. An atom with complete octet configuration is chemically inert and it does not participate in any chemical reaction. Example, noble gases. Except helium, all other noble gases possess the octet configuration. The atoms of element with incomplete octet configuration are chemically active. ये chemical reactions में actively participate करते हैं. They combine with other atoms to attain the stable octet configuration. The chemical activity of an atom is dependent on the number of valence electrons. You should be wondering why some elements gain electrons while some lose, कुछ एलिमेंट्स गेन कर लेते हैं तो कुछ लूज क्यों करते हैं इलेक्ट्रॉन्स? Atoms of elements lose or gain electrons just to attain the octet configuration. Just now हमने देखा कि सोडियम की वैलेंसी 1 है एंड क्लोरीन की वैलेंसी 7 है. सोडियम loses an electron and attains the stable octet configuration. 1 इलेक्ट्रॉन लूज करके octet configuration अटेंड करना ज़्यादा ईजी है rather than gaining 7 electrons. Chlorine atom has 7 electrons in its valence shell. It requires just 1 more electron to attain the stable octet configuration. So to achieve this, chlorine atom gains an electron. ये एक इलेक्ट्रॉन ऐड कर लेता है अपने में. 1 इलेक्ट्रॉन गेन करना ज़्यादा ईजी है rather than to lose 7 electrons. So friends, that's all for today's lesson. Hope you have now understood how the subatomic particles are responsible for all the variety around us. Hope this class was fun and interesting for you. For any information or if you have any doubt, you can surely visit the following link.